and welcome to the platform of Codechef. Today we're going to be solving the problem collision in space. The difficulty level for this problem is easy and the prerequisites required are your implementation. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try and understand the problem statement. Did you hear about the Nibiru collision? It is a supposed disastrous encounter between Earth and a large planetary object. Astronomers reject this idea, but why listen to the other people's beliefs and opinions? We are coders above all. So it is way better to code and verify using a small code. The Earth and n asteroids are placed in a 2D plane. Each of them is located at some integer coordinates at time equals to 0 and is moving parallel to one of x or y axis with constant velocity of 1 unit per second. The direction of movement is given as u, v, r, and left denoting up, down, left, right. Right? Given the initial position and direction of the movement of the Earth and each of the n asteroids, find the earliest time at which the Earth collides with one of the asteroids. If there cannot be any collisions with Earth, print safe, you can ignore the collisions between asteroids. They continue to move in the same direction after the collisions between them. Okay, so let me now summarize what the problem statement is saying. The problem is saying that you're given n asteroids and I'm giving the initial location of the Earth. So basically I'm given the position of x comma y and I'll be given a direction dir. Say if my direction is right, then I'm moving on the positive x-axis. If it was left, then negative x-axis. If it was up, then positive y-axis. If it was down, then negative y-axis. And then each of my or my initial any of my coordinates or any of my Earth or asteroids are moving only in one direction, that too at a speed of 1 meter per second or 1 unit per second. So what the problem is saying that you have to find the minimum time between collision of Earth and an asteroid. And if there is no collision, you have to print safe, right? So now to approach this particular problem, now let us first understand some kind of observations. Okay, so here the constraints for this problem are very small, such that my x comma y are lying between minus 100 to 100 itself, and my asteroids are less than equal to 1000 or somewhere near 10 power 3. So what you can do is, for my xy between minus 100 and 100, I know that my entire thing is in a 100 cross 100 grid. And since I'm moving parallelly in one direction, I know that my Earth to be present in the grid, it can maximum take 200 times, right? If it is at minus 100 and it is moving on the right side at a speed of 1, then it will take time 200. So what we can do is, for entire time of 200, also my answer can be in decimals. So say my Earth was currently at point say 1 comma 0 and my asteroid was currently on the point 2 comma 0. Say my Earth was moving in the right and my asteroid was moving in the left. So they'll collide at the point 1.5. So as a result, they did not travel 1 second, they traveled zero point 0.5 seconds from this point onwards to collide. So what we can do is, instead of keeping our counter as 1, we can keep our counter as zero point 0.5 to deal with those particular observations, right? So yeah, whenever they're colliding in between in such a way, we can just check for zero point 0.5. So the entire grid they travel half distance, we'll know exactly at which point we're going to collide. The idea for this problem is simple. What you'll do is, you'll traverse in all my 200 seconds, or basically the maximum time. So you'll keep your time counter as zero point 0.5. You'll increment your time. Initially, let's say my time is 0. Let's say my constant is zero point 0.5. So I'll simulate the entire thing, or basically I'll check whether my coordinates of Earth, let's say x comma y, is same as any of the coordinates of asteroids, say ax comma ay. Then what I'll do is, at time zero point 0.5, I'll increment my x with zero point 0.5 or whichever position according to the direction given. So say if my Earth was traveling in right direction, I'll increment my x with zero point 0.5. Say it was traveling in up direction, I'll increment my y with zero point 0.5. Say it was traveling in left direction, I'll decrement my x with zero point 0.5. So x minus is equals to zero point 0.5, and so on, whichever direction is given, right? After doing so at time zero point 0.5, after incrementing x and after doing the necessary updates on each and every asteroid and Earth, what I'll do is, I'll again check whether my x comma y at any given point is equal to any of the asteroid's coordinates. And if it is that the case, I know that it is gonna collide with that asteroid, and I'll note the time that this is the minimum time at which my Earth is colliding with one of the asteroids. And I simulate this for an entire time. So for time equals to 0.5 we check, next we'll check for time equals to 1, next we'll check for time 1.5, then 2, then 2.5 and so on up till we traverse a total distance of 200, right? There's the idea, the time complexity of this approach is nothing but O of 200 into around 1000, which is around, which should easily pass the question in the given time limits. So yeah, this becomes the approach to solve this particular problem. Now you'll get a complete understanding of this particular approach when you see the coding section. Let us proceed to the coding section. Okay, now let us try and understand the code for the following problem. Here I include all my necessary header files. For each of my test cases, first I include the number of test cases. For each of my test cases, I input my x, y and the required direction in the according to the input format. And then I initialize my x and y as integers of x and y. Then for my n, I input how many asteroids are there. For each of my n, I input again my x, y and location of those particular asteroids and I append everything in an asteroid array. Right? After that, I do the exact thing as I said in my approach section. I initialize my time is equals to 0 and then I initialize my answer as a big number which is infinity. Then, while my time is less than equal to 200, what I do is I traverse for all the asteroids and say if any of my asteroid is equal to if my any of the asteroids x coordinate is equals to x coordinate of Earth and any of my asteroids y coordinate is equals to y coordinate of the Earth, then I initialize that these two will gonna break these two are gonna collide and my time is nothing but minimum of answer which is infinity initially and minimum of the current time. So time taken is initially 0 and then we'll keep on increasing the time. So this is the answer if any of the asteroid is colliding and I'll break the loop that this earth will be destroyed by this particular asteroid. After that I'll traverse in my n loop. If that is not the case, then I traverse in my n loop and I check which direction of asteroid or basically according to the initial direction of the asteroid what I do is I update the location of asteroid. So if it was up, I increment by 0.05. So I discussed why I use 0.5 in the metric. If it is down, I'll decrement by 0.5. It is right, I'll increment by 0.5 on the x-axis. And if it is left, I'll decrement by 0.5 on the x-axis. And similarly for my earth, there's the increment of earth and decrement of this particular earth. And I finally initialize my time as 0.5 that after doing this time of 0.5 has passed. And after that if I check if my answer is still is equals to float infinity, that means my never any like in all of my iterations not even one asteroid hit the earth. That means my earth is safe and I initialize my answer as safe that no earth is safe after this entire iteration. Otherwise the answer is the answer that is going to get computed here. Yeah, this becomes the code for solving this particular problem. Now let us run our code on the sample test cases to understand whether everything is working correctly or not. So as you can see, we got the exact output according to the output format. Now let us submit our code and see whether our code passes everything successfully or not. Okay, so as you can see, we got the correct answer verdict for the following problem. And yes, this becomes the correct way to approach this particular problem. Okay, now let us discuss what mistakes people can make in solving this problem. So here, according to the constraints for this problem, you could easily implement the problem for each and every time in the given problem. So yeah, this way the problem was simple to implement and yeah, you could implement it easier. Any other approach than this could be a little bit complicated, but yeah, I think this is the best way to do this problem in the following constraints. Yep, this is the learning you get from watching my video. I hope you like this video. Please like, share and subscribe to our channel. Thank you.